In our last video, we looked at angles in standard position. In this video, we're going to discuss a specific type of angle, which is a coterminal angle. And that is to say that angles that are coterminal are terminal together or terminate together. So our definition of coterminal angles is simply two or more angles that terminate on the same ray. And so you can see below here that I have a couple of illustrations of coterminal angles. We see these Greek letters alpha and beta that represent these two angles. But in this first illustration, you can see that maybe we have some counterclockwise or positive angle alpha that terminates on this ray here. But we also might have some clockwise or negative rotation angle that also terminates in the same spot. That is to say that A and B in this sense would be coterminal angles just because they terminate together. And likewise, if I were to have some angle here, alpha, that maybe terminates right here, I might also have some other angle, beta, that terminates there, but also makes another full rotation. And so they stop in the same place. A and B also would be coterminal in this sense. So with respect to coterminal angles, the neat thing about these is that they can be found by either adding or subtracting multiples of 362 or from the original angle there. So to look at how this kind of plays into finding coterminal angles, we're often going to be looking at sets of angles that all terminate in a specific spot. It's easy to find coterminal angles just by adding on or subtracting on increments of 360. So in these two over here, what I want to do is sketch the angle in standard position, but then also find a positive and a negative coterminal angle. So looking at our first angle here, which is a negative angle, this would mean we rotate in a clockwise fashion. And knowing that our quadrantal angles here are negative 90, negative 180, negative 270, and I suppose this would be 0 or negative 360 here, we'd have to rotate in a clockwise fashion about 75 degrees, which would put us, if we want to do a little bit of calculation here, about 15 degrees shy of negative 90. And here's how we would illustrate this right here, negative 75 degrees. In order to find a positive coterminal angle, here's what we'll do. We'll just add on 360 degrees, but the reason why we're doing this is because if we were to rotate one full rotation around from this, we would end up in the same spot we started at in terms of a rotational angle. So in this case, we would get negative 75 plus 360, and I don't have a problem using my calculator here, plus 360, looks like we get 285. So 285 would be another angle that is coterminal with the given angle. And if we were to take negative 75, for instance, and subtract off 360 degrees, well, then we would end up with, I suppose, grabbing our calculators again, negative 75 minus 360, we would get negative 435 degrees. And these would both be stopping in the same place as the original angle. We could just go ahead and illustrate the first one here. If we were to graph a 285, that would be at least 270 in this direction plus another 15. You could see that a 285 degree positive angle would be coterminal with a negative 75 degree angle. So again, with like letter B here, 460 degrees, where would this lie? We know this is at least one full rotation in a counterclockwise direction. What if we took our 460 minus 360? Well, it looks like we would end up with 100 degrees left over. So this 460 terminates in the same spot that a 100 degree angle does. And given that this is 90 right here, 100 degrees would kind of stop maybe about 10 degrees past there. So to illustrate this, we're going to say 360, a full rotation, plus another 100 right here. This is our 460 degree angle. So in order to find a positive and a negative coterminal angle, in this case, we're not going to add on 360. I'm going to subtract off 360 degrees, which gives us, here's our positive coterminal angle. But I'm also going to take that 100 degrees and I'm going to subtract off another 360 off of it, because this would give us another angle, which in this case we needed a negative angle also, that's also coterminal with it. And just to go ahead and show you why negative 260 might be coterminal, looking at this, a negative 260 degree angle would start on the positive x-axis and rotate around 10 degrees shy of negative 270, which drops you in the same place right here. So the key takeaways here are the coterminal angles both end in the same place or same ray, and also that you can find coterminal angles just by simply adding on or subtracting off increments of 360 degrees to your initial angle. Cheers.